All right. Good morning. I think we're on here. Great. Cool. So let's just continue on what we did. Again, I kind of want to point this out at the start of every stream in case someone hasn't seen it. So what we're basically doing on the stream is that we're trying to deal with some new challenges that Codesandbox has realized, and these are general state management challenges. So we have overcome some challenges, and then we've identified new stuff. And a lot of it is well, not a lot of it, but some of it is related to TypeScript, like structuring your project to take the most benefit out of typing, but also like general stuff. And I remember back in the days, people like asking questions about concurrency, and I was like, why do you talk about concurrency? Because JavaScript is single-threaded, and I think what people mostly mean when they talk about this kind of stuff is like, how do you deal with asynchronous code? Is there anything in the tool that ensures that you do asynchronicity correctly? And there's so many different parts to asynchronous code that can kind of trip you up. And anyway, so we're not dealing with that in a good way in Codesandbox. And at the same time, it's this idea that Codesandbox it really wants to. So you have two different kinds of tools. You have things like Webflow, for example, where you kind of take on the perspective where you say that, okay, we are going to give you a full fledged editor, which is UI based, and we will produce the code for you. You don't have to touch any code. That's one perspective, and that's perfectly fine, but it has some serious limitations. Like it works well for websites, but when you get into actual applications, it becomes very limited. And the other perspective is like, okay, we have this code, and this code is the state of the code. And what we need to do is build UI tools on top of that code. So we analyze the code that produces the state. That is the state that produces the UI, or the UI is based on. And what that allows us to do is, like all my previous visual tools has been runtime debugging. So in the runtime, it sends information about what's happening, and it populates that in a UI. But this time, it doesn't even need to run the application. It analyzes the code and produces a UI based on that code. And what that allows us to do is also manipulate the UI of the editor, and that will produce code which again will be the basis of the state that produces the UI of the editor. Anyways, so we've been playing around with Codesandbox, and we're going to continue doing that. And we talked about how features is a good a good abstraction to think about when you're going to implement something. But features depends on other features. That's just the way it is. And they don't necessarily have like parent features. They also have sibling features. So you have this thing where you basically have sibling dependencies. And not only that, but they can depend on each other. So you have circular dependencies. So that is what we're dealing with here. The API is what is responsible for exposing the endpoint for signing in. But the other endpoints, that's also part of the API, like getting a sandbox and everything like that, also needs to know about the authenticated state of the user in the application. So they have this circular dependency, which is like a natural circular dependency. And we're allowed to do that here. Anyways, we did talk about splitting up the API. We got a suggestion about like repositories, and it made me think that we can actually do something here. So what I want to do is I want to take a look at this API And we are rather going to expose some convenience methods here. So this API is responsible for just talking to the server, which means that it only has like convenience methods for get, post, patch, and delete. And on get, we have a URL, or let's call it path. And optionally, we have a T request query here. And what we're going to do, yeah, and then we have, oh my God, I didn't get that much sleep last night. The newborn didn't behave. Like you change one tiny routine, like it's so fragile, like getting into a good routine with a baby. Just change one little thing and then, yeah, was crying when we went to bed. And then our daughter woke up and then, yeah. So I got like 6 hours of sleep or something, which is not ideal for me. Anyways, so let's fetch. And we're using generic, that was the word. So we have a method here, which will now be get, and then we only need query and path like this. So let's create these convenience methods. We need post, we need a path here as well. We need some data. I think we typed that as object, might not be the right thing to do, but I don't care. Request query, and then we also have data here. And we need a generic there to, this is like the return type. And then patch is basically the same thing. Path, patch, it should be patch. Patch, what? Isn't patch, oh, didn't I add that? And then delete. Okay, something like this. Patch. Did I write it wrong again? No, patch. And then we have delete, which takes a path, and I can also have a query actually, T request query, but no data. Generic, and oh, what did we miss here? Here, delete. Okay, cool, it's happy. So what I thought we could do, this is the thing that's responsible for, as I said, talking to the server. It ensures that we add the JVT token if that's available. But actually using the API, we can add that as different features. So we can have Sandbox API. And like, what's the term we should use there? That's up for discussion. You can use like repo, endpoint, whatever. But this is going to use, so the auth is not going to use API directly. We're going to do this, and then auth is going to use not the Sandbox API, but we're also going to add a new feature called auth API. Like this. And that's also using the API. And that is what auth is going to use. Let's see. Oh, sorry. Yeah, I think I have an issue with, oh, sorry. Yeah, I have this bug where I can't attach multiple, let's see, auth API. I can't attach multiple links. I have to fix that. Let's see. Are you happy now? Yeah, sorry about that. Okay, I need to fix that. And also something I want to do, sorry, I'm jumping a little bit here. I'm going to make these folders instead of files so that you can add tests and other utilities to your features. And we're actually going to look at testing as well. It's pretty cool how it works. Anyways, yes. So now we have this general API thing. And what I like about this structure is that now we have this strong concept of authenticating with a server and getting sandbox information from a server. And we are currently using the API to grab that data. So this is the contract with the app. It's here, right? And it doesn't matter how we grab that data. So what we're doing at Codesandbox, we're kind of transferring to GraphQL. So what we would be able to do here is that, okay, now we want our sandboxes to be grabbed from GraphQL, and then we could just have, instead of API, we would have a GraphQL feature. And then that will be attached to Sandbox API instead, and the contract is the same with the rest of the app. That's pretty cool. But yes, so this is what I wanted to do. Let's move. Let's see, let's move. Get Sandbox should be here. What we're going to do instead is going to say this API get like that. And then what we can do now, oh, did I go to the auth API? sorry. Sandbox API. So what we can do now is that we can move the types. Now we can actually make Sandbox DTO part of this thing, which makes more sense. Let's see, there we go. Sandbox DTO and current user auth API. Current user. And we'll do the same here. Yeah, and I actually, this API get, I forgot that we have this, we have our own special way of logging in locally. So we'll have to, I'm going to fix that, but I'm not going to do that with you, I think, just because it will take some time, and I need to do a little bit of research. Well, we'll see. Maybe we'll do it together. But anyways, it's based on like us. It's the way you log into the CLI. If you use the Codesandbox CLI, you get this pop-up thing. You copy a token that you insert, and it's the same thing here. And I haven't actually looked at that code, so maybe that will be a learning experience for all of us. Anyways, so now we have, oh, where did I go? There we are. So now we have these things. We have our auth API, our Sandbox API. Yeah, and the endpoint will probably be, oh, sorry, the environment will probably be something that several things depends on. But what I thought we could do now, I want to show you how this approach of dependency injection or feature injection works. And I don't know if I talked about this, but dependency injection is, all implementations I've seen of it is very generic and low level. And I also said I've never seen it before. Of course I've seen it. Angular does this all the time. But they also have quite a low level implementation of it. So it's interesting to see that kind of feature being like a first class concept in a tool. Like not just being a dependency injection tool, but actually being like a state management tool. And then you have dependency injection as part of that, as we're doing here, because then you can do some really cool stuff. As you can see with all the debugging information, you can see all the instances being created, you can navigate through them and everything, which is really, really cool. Anyways, what I thought we would do is kind of quickly look at testing before we continue building up how this would look like. So I already installed Jest here. You can see I have an auth test. And with this is one of the strong points for dependency injection, is that if we import auth from app auth, we're also going to import container from reactive app. What we can do here, we can actually let's see, auth. Container is new container, and we're going to attach auth here. So auth is going to work so we're kind of building a new application here, but we're only using the features that's related to our testing. Now, the thing is that auth depends on the auth API, right? So auth is a dependency of API, but what it depends on, like what auth depends on, is the auth API. So what we want to do, we basically just want to mock that, right? So what we can do here is that we can bring in our auth API like this, and then we have this function called mocked auth API, and all we have to do is say mock auth API, and the second argument gives you the methods of that instance. And what we can do now is just say when we sign in, what we want to happen is turn promise.resolve, and I think this is supposed to be, what is this supposed to be? Yeah, iCurrent user, yeah, like we have JVT123, for example. So this is typed. This is based on the actual auth API. So this is our test. We have auth API, and that will be the mocked auth API. Cool. So what should happen now is that we should have our auth by going to the container and getting auth. So now we have an isolated auth where we have mocked out one of its dependencies, where we have a successful resolvement of signing in. So what should happen now is that when we do auth sign in, and we kind of have to wait, should we just, I guess we're just waiting for a single promise here. Let's see, watch auth test, yes. Let's make it async. I think we can just wait for promise resolve, because we kind of have to wait for this one to resolve, right? And it's just a single promise, so this should be enough. And now the auth state current, and I like to do this because then it's typed. It should be authenticated, right? Let's see what happens. At least my reasoning should be sound here. Oh, sorry. I thought I had put everything. Oh, bubble preset, TypeScript. What are you complaining about? Oh, is it? Oh, sorry. Oh yeah, we need. Oh yeah, I know what we need. Sorry. Bubble class. What's it called? Class plugin class properties. Assignment. Is it class properties? Yes. Property initializer syntax. So we need this one. Let's see. Let's install that. Oops. npm install say dev. Now we have to link back our reactive app. Whoop. And then I guess we should have that one. Oh, that should be a plugin. Bubble plugin proposal. What's it called? Class properties. I think that's it. Let's see if it runs now. Yeah, and it even passed. That's awesome. Okay, but this, yeah, I'm glad this kind of just worked, because what you were able to see now is the benefit of dependency injection is that when you want to have these isolated features, like even though they are isolated features, they rarely are isolated, as we talked about. They do depend on other things. And with those things being injected, it's very easy to mock out them during testing. You're basically setting up a brand new application which only has the features you want to test, and you can mock out any of them. Yes, that's cool. That's pretty cool. Okay, so that was that stuff, and now let's try to explore some more here. What we want is, yeah, this doesn't actually need to be. I should be. You can actually run methods even though they're not actions. It's just that it's not tracked. They're executions. So maybe we should have run here no matter. Anyways. So what I thought is that when we, and this is also something that, like, authentication is really tricky, because how do you want it to work? Do you want to, should we verify the user before anything happens in the app? So visually you would imagine that, okay, Codesandbox starts with auth. And it's not until you're authenticated or unauthenticated that the rest of the application fires up. And that would mean you wouldn't see anything on the page, right? Because we want the Navigator to start when your authentication state is resolved, I think. Well, that would be one approach. Like, that's the first thing we do. We figure out, are you authenticated or not? And based on that, we start mounting up the rest of the application. Or do we make the Navigator the front of your app? And then authentication is just something that happens next to it. And that's what I want us to do here, because in Codesandbox, for example, when you go to the editor or a sandbox, you kind of see something immediately, and then it starts resolving your authentication status and stuff like that. And when it figures that out, then it starts loading stuff up. So let's try that. And what we're going to do is add a feature called Navigator. And this Navigator is responsible for, basically it's the router. We could have called it router as well. But for now, let's call it Navigator. And what we're going to do with this Navigator is, it doesn't really care about the authentication state. Well, yeah, it doesn't care about that. Like, you could say maybe there are certain pages that's only supposed to be available when you're authenticated, but then that would be something that that page specifically deals with. It would not be what the Navigator deals with. So you can imagine that every page behind the Navigator, they will depend on auth, and themselves decides, okay, what should happen when you're authenticated and what should happen when you're not authenticated. And we're going to explore, like, how do we wait for, how do we handle when that state changes? How do we handle when we're initially authenticating, we're waiting for the authenticated state and stuff like that. And this is what I find fascinating with tools like Redux and Overmind and Vuex and all these tools. Like, in that world, I never really thought about this stuff. And it's like, building web applications is really tricky, especially when you want to do it right. You want to ensure that things are only running in the correct states and everything. It's interesting to me that it's so kind of easy to go in and build something, but to build something the right way, especially in terms of asynchronous applications, it's actually very, very difficult to do. And that's why I hate examples like the to-do example. And even when people create games in UI frameworks that's built to build applications, it's that they're not asynchronous. And that's where the tricky parts come in. Anyways, I'm rambling again. Okay, so let's just try to explore this concept a little bit. So what we can do here is, or what we should do here, is that the Navigator basically are different pages, and each page is a specific state. And what we want to happen when we move between these pages or navigate between these pages is that it disposes of whatever was on the previous page. That doesn't mean that it needs to dispose of all the data and stuff, but that's more of a caching solution. That it's not something like if we move from a sandbox to from the editor to the dashboard, we want to dispose of the editor. That doesn't mean that we necessarily have to dispose of the sandbox data. That can be cached somewhere. So if you were to hit the back button, you wouldn't have to fetch everything again. But that's something else. This is basically when you move between pages, we want to ensure that we're unloading whatever we were doing. So for example, if you were in the editor, you were doing something asynchronous and you move to the dashboard, we want to dispose of whatever you did asynchronously so that doesn't suddenly pop in or change some state under the hood or whatever. Okay, so let's take a look at that. Let's make it a state machine, and let's go in and create a couple of routes here. Let's see, Navigator. Home. Okay, so we're going to use this term requested. Or here we could use the term routed, for example, because we do want a router. This to be based on a router, but let's just use this requested thing. So for example, we have, let's just call it home requested, and editor. So this is the message is what happened. Like this is something that happened in the app, and we're calling it home requested now. Or let's call it routed, because that is really what happened. So home was routed, or editor was routed to, or navigated. I don't know. It can be what. I don't fucking care. Home and editor. And these are the two different states we can be in at the moment. We'll start on home. And let's see, what we're going to do is, yeah, I think I'm going to remove this switch thing, because as soon as you start messing around with the, yeah, I'm not sure. Anyways, so the message type, maybe we can have like the switch, but not the case. That would be nice. Anyways, so if you are on home, we just want to return current home at the moment. Oh, sorry, home routed. If you try to go to editor routed, we are just going to go to editor for now. Okay, and then we can say, let's just call it home. Return this, send home routed editor, and this would have an ID, right? Return this, send type editor routed. Okay, so this is like complete overkill for a state machine because we don't have any guards or anything, but that will most likely change. But most importantly, as I said, the state machine automatically disposes of the existing state when it changes to a new state. So when it moves from editor to home, it will look at all the state here, and if it finds a feature, it will dispose of it. That's the important part. Yes, okay, so let's add the ID to editor routed ID. Cool. So what we want to do now is whenever we move to editor, we want to create a new editor. So let's create that feature, the editor feature. And since, so this is the thing, like what should be factories and what should be singletons. So environment, API, auth API, sandbox API, auth, and even Navigator are all singletons. And they are singletons because the context is always the same, if that makes sense. Or how should I explain this? Like, what's my reasoning for... The point is, we're going to make editor a feature. And why do we make it a feature? Yeah, it's a good question. How should I explain this? So, okay, so let me try to explain from this perspective. A singleton can't be disposed, right? It's always there. And even though auth has like different contexts, by the way, I might change that. Instead of state, it should be context. It makes it easier to talk about state machines, because then context.current would be like, or it would be like context.state. That's the state it's in. Anyways, you can't dispose of singletons, then they're always there. But we want to dispose of our editor, right? So whenever we move to a different page, we want that editor to be disposed, and we want that. That's why we want it to be a factory. And yeah, what I'm trying to find a good explanation for is like auth might have different users, an editor might have different sandboxes. So why isn't auth a factory? Yeah, like I know this is the right thing. I just can't find the words to explain why it should be like this. Maybe I can try to explain it. Okay, let me try to think about this. So another thing is the power of a singleton is that it can be used as a dependency to any feature, and it will always be the same instance. If it's a factory and you use it as a dependency, you don't get an instance. You get the ability to create an instance. So if you create an instance of a factory, it means you need to pass it around. So it's basically, if you have something that you need to share across a lot of features, you want it to be a singleton. And if you get into a situation where the context of the feature can change, so for example with auth, it can change the user, you deal with that manually because you prioritize making auth single instance because there's so many features that depends on that, or depends on it. While the editor, is not something that a lot of stuff depends on, and you kind of just want that automatic disposal. So you want the other features of a factory. You prioritize them higher than the singleton. Yeah, this is interesting. I imagine like if this were ever to be documented, you would have kind of like when to use a singleton and when to use a factory. And it would basically be something like that. So there are benefits to a singleton, there are benefits to a factory. It depends which one you want to use. Yeah, that's the answer for now. But let's make this editor a factory. I even have this nice blue factory icon. That's important. Okay, So the editor cares about authentication. It doesn't want to go and grab a sandbox until it knows if you're authenticated or not, because the response is different based on your state, based on your authentication state. So let's, oh my god, I have to fix this so we can do multiple links. Sorry about that. Yeah, I wonder why that doesn't work. Why can't I do it multiple times? Anyways, so that needs to depend on auth, and our navigator is what's going to create the instances of the editor, so it needs to depend on that. And as you can see, it automatically understands that it's a factory, so it says create editor, and it's a function instead of being a class instance. That just works. Okay. So, so what are we going to do? We are going to go into the navigator, and we are going to create an editor whenever we move into the editor state. So that means, where are we? Here on our editor state, we want an editor. And that should be editor, like this. So this is an instance of editor. And when we move to that state, we're going to say editor is this, create editor. Cool. And what we're also going to do is we're going to say that the editor takes a sandbox ID, and that means this is now typed to take a sandbox ID, and that ID comes from the message. So the router calls editor because that's the route. It gives it the params, which is the ID. The navigator sends a message into the machine and says that, hey, it's requested that we want to move to the editor thing. This is what happened. You go and figure out if this is a transition that we can do. And in this case, we can always do a transition. But we might have some guards here. Anyways, it returns the new state, which is editor, and it creates that editor with information from the message. And again, this seems very ceremonial, and it kind of is, especially when you look at this example, because there isn't any guarding or anything. But as things becomes more complex, it's really, really important to have this. Yeah, and especially that one thing that's kind of the core here that you can't really see in the code is that it disposes automatically whatever features are attached to the current state or the context. I think I'm going to call it context. Yes. Anyways. Okay, so now when we move to editor, we get an editor. And now it starts to get interesting. Because now we're going to start to deal with asynchronous code like properly in terms of it being disposed. So what if somehow, like this can happen, you open the editor, the authentication is taking a long time, and then somehow you were able to navigate to home, which means that we need our editor to wait for the authentication state to become authenticated or unauthenticated before it actually does something. But what's nice is that we actually do instantly move into the editor state, which means that we can show like an editor skeleton and all that stuff. But we don't show anything until we know the authenticated state of the user. So how would we do that? And this is really interesting, and this is why I like to have the reactivity inside the tool. because so for example, MobX, whenever you do like a reaction of some sort, it returns a disposable. Like it returns typically a function that you can call, and it will dispose of that reaction, so it doesn't trigger. Or it can also return like a promise that has a cancel method on it to cancel that reaction. But the thing is, you have to deal with that manually, and that's not ideal. Like you want things to dispose for you. It's kind of like if you looked at the Rust language. This is interesting. So as a concept, you want things to be disposed automatically when it's not used anymore. In JavaScript, you have, like in terms of memory disposing, in JavaScript you have the garbage collector, and it kind of triggers from time to time, and it looks at whatever is not being referenced anymore, and then it disposes of that. And that is okay, but it has some drawbacks, which is like it can trigger at the time where you're doing an animation, for example, and suddenly you get a jank, stuff like that. In Rust, you have a different approach. And then you can go to the other side. You have like C++, where I have never written C++, but the way I understand it, you have to manually dispose of references when they're not used anymore. Kind of like what MobX does, right? You create a reaction, it returns a function, and you have to deal with disposing it. And that's a source for bugs. But then you have something like Rust, where it understands that when you create a variable inside a function and the code runs at the end of that function scope, then it will automatically dispose of whatever was inside that variable. So Rust understands everything and disposes everything for you. And that's what we want to do here as well. So as I said, these factories, they are disposable, which means that you can register disposers on it. So let me show you the code for that. Let me just create like a constructor. Sorry, we're in the constructor. So here we have onDispose. Well, first of all, I can dispose of it like this, but we also have this onDispose. So you can register like a reaction call, a reaction disposer in onDispose. So if I create a function here, this function will be called whenever this editor is disposed. Right? So what we can do with reactions, which is what we're going to use now, is that when it's integrated into the tool, we don't have to think about that. So for example, if I say this reaction, and I have some code here and some code here, this is like a reaction, I don't have to think about disposing this. This will automatically be disposed whenever the editor is disposed, right? So that's a good thing. It's something I don't have to think about. And if you ever played like with Backbone, they actually have something similar. They have this thing where you, instead of listening to an event with like on, you have this listen to some event. And what this means is that if you were to do object on, so you get like a disposer, if you were to do this, you would have to manually deal with disposing it. But since they have this internal disposing mechanism inside their views or whatever, you can say this listen to object some event, and that means that it will automatically, if the view being this is disposed, it will remove it from, so the event is still being listened on the object, but since we're using listen to, it will automatically remove that listener on the object whenever the view itself is disposed. But what it could also do is, if the object is disposed, it will also remove the listener because it's not valid anymore because the object has been disposed. So you it can happen both ways. I hope this makes sense, but it's something I've never really thought about. But now I'm thinking a lot about it. So what we're going to try here is that, as I said, we don't really want to do anything here until we are authenticated or unauthenticated. So the question is, how are we going to deal with that? So there are two parts to this. One thing is just figuring out when that state changes. And the other part is, how do we guard our logic? So how do we, we're going to expose some methods on the editor to do certain things. But those methods should not be called when we're still waiting for the authenticated state. So I'm not sure how we're going to deal with that, but this is what we're trying to solve. This is something that should be dealt with in applications, and we're just going to try to use this concept to see if we can actually deal with that. You can say, why does that matter? Like in the UI, you can't click anything. It's a skeleton until stuff is actually loaded. And yeah, that's true. But at some point, maybe there's a button there or whatever. It doesn't matter. Something can cause that method to be called in an invalid state. You don't know that, and typically you will not be the person who finds that issue. It will be some user. Cool. Okay, so what we have a possibility to do, this is not like fully implemented, but MobX has different reactions. So one of them is when. So we can say when this auth state current equals authenticated or unauthenticated, we want to well, now it's kind of weird to call it unauthenticated. Oh, this on auth. Let's bind to this. On auth, this is like a private thing. Okay, so what this code means is that whenever we instantiate an editor, it will immediately look at the state of auth and see if it's authenticated or unauthenticated. And when that happens, it calls this method. So if it's already authenticated or unauthenticated, it will immediately call this. But if that does not happen, it will wait until this is true. This is how MobX works. And the reason it will wait is because we're looking at this property. So whenever this property changes, it will rerun this when callback. And whenever it returns true, then it will run this method, and then it will dispose of itself. But the cool thing is, since we have tied this to the feature itself, like using this.when, it will actually dispose of itself as well if the editor is disposed. So if you move from the editor to the dashboard while it's figuring this stuff out, it will stop figuring that stuff out when you move to the dashboard, which is important. Cool. And now the question is, what are we going to do now? So, as I said, we want to guard some methods here. We want to expose some methods, but we want to guard their usage, because the methods shouldn't be available at all states. There are basically two different states here. The editor is either like loading or like waiting for authentication. I guess we can call, oh, I'm out of focus. We can call it loading because it includes authentication and fetching the sandbox, because the editor can't really do anything without the sandbox. And that sounds like we should actually use a state machine here, because that gives us the ability to do this guarding. So even though we have like a factory, we can still add like a state machine. And I want to explain, like, I'm not saying that all applications needs to think about this stuff and should do it. It doesn't matter. Like, this is just one implementation, but all the abstract stuff I'm talking about, like race conditions and states and all this, like, not all applications like have to deal with this. It's a trade-off. Like, because you can, yeah, as I mentioned, Heroku, they work just fine without that, with that bug on the login page where you keep clicking the login button and it never logs in, and there's no indication in the UI that it's trying to log in. Like, you can live with that, because there's a cost to like introducing a new tool and stuff like that, and there's also like a complexity thing. Like, is this a tool that would be used by like hundreds of users, thousands of users? Because the increase of users also increases the different contexts the users can put themselves in. So for example, Codesandbox, we hope this will be used on schools, for example, which probably means that the same computer will have many different users. And we want to ensure that one user doesn't get data from another user and stuff like that. And that might not be as important in a different application where it's more of a personal thing. You only log in once and then you're kind of logged in all the time. It's more like a grown-up kind of, yeah, it doesn't matter. You know what I mean? So like, it's definitely a trade-off, but I hope it's interesting, the stuff I'm reasoning about, because it's a real thing that we don't really deal with that much. And you can say, for example, React and components, they actually do deal with this stuff. It wasn't like clear, but the way the hooks work, having the possibility, so for example, use effect, you can return a function to dispose of that effect, and that's basically it's the same concept. Like, you're firing up some asynchronous thing, and you want to dispose of that when it's not valid anymore, when the component unmounts, right? The thing with React is that it kind of re-triggers things all the time because it recreates the effect, and that can be a little bit mind-bending, but it's the same concept. And yeah, and actually working on this, I was thinking about, like, it's really interesting how React does this specific thing, and also how it has its context providers, which is basically a dependency injection system. So you could, I did try to kind of, okay, so I've been working on this stuff, and then, okay, let me go back to React and think about how I would do this in React. Now, the problem with React and its like dependency injection is that if you create like hook, how should I call this? Like, if you create a component, a provider, and it has some state, and you want to change that state with some actions. The problem is that whenever that state changes, there's so much work being done there, so much unnecessary work. And what happens is that you kind of want to pass the actions and the state as an object. That's what you want to inject into the different components. But the problem is, like, how do you do that? Because you have a state object and you have an actions object containing all the actions. And then what you would typically do is, like, let me show you in code. You would typically do something like, oh my God, I'm really going way off here. So you would have like a function. So let's call it editor. So this is like a provider component. It's just, it takes some children. So you could kind of do the same thing. And then you have like, we created a provider here, which has a value, and then children, right? Now the thing is, you want some state here. So let's say state dispatch, and then it's like use reducer, blah, blah, blah. And then you want some actions. So how would you express that? Maybe actions, and then you would do change foo. And then that would have to be like use callback. Use callback, and then you will kind of do this, something there, and that this would have to like depend on state foo, for example. And you can do this. This is perfectly fine. Like you just want these hooks to run in order, and they still do that, even though we kind of intertwine them. But now, like, how would you be able to pass the state and the actions? Okay, I can do state actions, but now every time there's a change here, every single component using the editor will re-render, because the object, like the provider object here, the value, it changes every time something changes inside the editor. And that's not what you want. You only want, so if you change foo, you only want the component that actually looks at foo to reconcile again, right? And this is the really, really tricky part. So you want this object wrapping here, you want that to always be the same. And then you want some reactivity to state changes. You don't care about actions never change either. And you don't really need to recreate these functions all the time. So imagine like every time you change the state here, it recreates functions for the actions, even though it doesn't need to do that. And it just does so much additional work, and it doesn't make any sense to me. But the mechanisms are there. They're just insanely slow. At least that's my initial reasoning about that. Maybe you have some other approach to doing that. I would love to hear that. Anyways, what the hell were we talking about? Oh yes, our editor. It should be yes. So it should have two different states. It should be loading and loaded. Or it could be pending and ready. Pending, yeah, let's do that. That's fun. Pending and ready. So it should start in a pending state, because it is in a pending state. And then the question is, how do we deal with different things? So anyways, when we are authorized, what we want to do, we want to go and grab a sandbox, and then we want to move into the ready state. So let's go and grab that. We make that a dependency. Maybe we'll have to, oh, it worked, great. So we have our sandbox API, and now we're getting into another disposable thing. I hope, are you staying along with me here? I'm afraid I'm rambling too much. Is there anyone here? Yeah. But yeah, I hope it's useful. So now we talked about, okay, we're waiting for it to be authenticated or unauthenticated. So that's something we want to dispose of if the editor is disposed. But now we're going to go and fetch a sandbox. And again, we don't want to do anything about that sandbox if the editor is being disposed while it's grabbing it. So how would we do that? First of all, let's make it async, because it is async. And yeah, so what we're going to do is when what should we call this? Sandbox loaded. And then we have the sandbox, and it's an iSandbox DTO, which we're getting from one of our... Oh, did I add observable? I have to change. Oh, I have to make a list. I have some things I want to change now. Let me just create a list here. Fix observable import on state machine. We talked about fix multiple dependency additions in editor. What else? Write features to folders instead of files. Okay. Cool. Yeah, so what we can do here, instead of binding it like this, we'll rather say this on auth. Well, okay, let's rather make it a private property, sandbox ID string, and then we'll say, let's change this around a little bit, and we say this sandbox ID equals sandbox ID, just so we have that on the instance. Oh shit, yeah, this happens sometimes. Oh yeah, this is one thing I don't like about the editor, is if I have changes to my file and it's unsaved, and then I go and change the file under the hood in the editor, then we get into this issue. Compare, and basically we just need to overwrite. Resolve conflict, is it? Oh, how do we do this? Don't say. Then we open it again. It's really annoying. I'm not sure how to deal with that in a good way. Anyways, sandbox loaded. Sandbox, and it's iSandbox DTO. From the sandbox API. And then we said we want a private sandbox ID here. So let's fix that. This sandbox ID equals sandbox ID. Now we have that. Let's remove this observable again. And now we want to, in our on auth, we want to make it async, and we want to try to sandbox equals this sandbox API, get sandbox, and we say this sandbox, oops, this is sandbox ID. Okay, so now we're trying to, so what we can do is this. The problem with doing await like this, and this is true for all, what's it called? Async await. This is true for all of them, because literally in your code, you're in one context at this point. Well, let's say from the perspective of the editor, the context starts here, right? You're in a context. And then, well, that's kind of wrong. It depends on if you're authentic. So let's say you are authenticated. So the context starts here. You go through here, and then you go in here, you are authenticated, and then it runs this synchronously. It runs this, and you're still in the same context. You're still authenticated, right? That it has to be that way because it's synchronous. But as soon as we do await, the context is, it's gone. Like, it's not gone is maybe the wrong term, but we're not certain of it anymore, right? So everything that happens after here, anything could have happened. We might have changed our authentication state. The editor might have been disposed because we moved to a different page. Like, anything could have happened here. And this is what we're not securing. So async await is really, it's just one piece of the puzzle. It's just waiting for some data. It doesn't deal with the surrounding context, and it shouldn't really, but we as developers in the language don't have any way to deal with this concept. And just try to think about this when you look at your asynchronous code. Like, what could theoretically happen after this await that would make the code after await not make any sense? In this case, it would not make any sense to start adding a sandbox, firing up more features and stuff like that. If you weren't authenticated anymore, because then the sandbox is wrong, because you get a different sandbox when you're unauthenticated. You might have moved to a different page, blah, blah, blah. You know what I mean? Yeah, so we have another state here as well. Oh, we forgot that. So we are pending, ready, or we might have an error. And that has a message, or let's call it error, which is a string. Okay, and the current is pending. And what we want to do, oh my God. Sandbox loaded. Sorry about this. Sandbox loaded. Oh, and I want this stuff to be. Oh yeah, sorry. I want the constructor. Oh yeah, so like when I so now I injected the state machine after I created the constructor, and now it suddenly appeared underneath here, and I don't really want that. So I need some more code to. Oh, did I remove my notes as well? Damn it. What I mean is that I want to ensure that properties are actually are written at their correct positions. So what was I going to do? I was going to fix make folders instead of files, feature folders instead of files. I wanted to fix adding multiple dependencies in editor. Damn it, I forgot the last one. Fix inserting properties with I'm calling it capabilities related to constructor, etc. And there was one more thing and I've forgotten it. Oh yeah, I also changed state to context on state machine, because I'm talking about it's the context of the state machine. Like the state machine is in a certain state and it has a context related to that state. It's much easier to talk about it that way. Anyways, yeah, I can't remember the last thing. Maybe it will pop up. Okay. So how are we going to deal with this? We are going to, yeah, so we have sandbox loaded, and then we have, let's move this up. We also have type sandbox error, I guess. And this message will send in an error. Okay, so we have this case and then we have the sandbox error case. Cool. So how are we actually going to deal with it? Let's just write this out first. So first of all, we want to send in a message that we loaded the sandbox, and what we should have here is sandbox DTO, and it is. That's nice. And then if something bad happens, we want to say we went to an error state and the error is error.message. Cool. So now we're kind of dealing with that. But as I said, we're not dealing with this await. And how we deal with this in this concept is that we basically have to do this. We could, yeah, so first let's talk about how we deal with this. So there's something called resolve. And all, I believe resolve is part of, is it part of, yeah, it's part of the factory, because factories are the only things that can be disposed. And what this does is basically it just yeah, so let me explain what happens. So it takes a promise, and when that promise resolves, it checks the instance, is it disposed? And if it is disposed, it will throw an error that it is disposed. And if it throws an error and it is disposed, it will also throw an error that it is disposed. Okay, so that's basically what it does. It intercepts the resolvement of the promise and throws if the factory is disposed, which means that when we catch an error here, it might be an error that says that the editor has been disposed, so we don't really want to do anything. And the way we deal with that is we just check. If it's disposed, then we return. Now, this isn't as automatic as the reactions and the disposing, but there's really no good way to deal with this. So in terms of try catch, but there is a different way to express this. What we could also do instead, we could say this resolve and then we could give it an object, and this object takes a rejected and it takes a resolved. And again, it gives us a sandbox here, so we will write it something like this, sandbox loaded, and like this. And this is an error. Okay, if you write this syntax, it's a little bit better, because what happens now is that if the editor is disposed and the promise is rejected or resolved, it won't run any of this. It just doesn't run it. It doesn't throw an error. It just doesn't run the callbacks. But you have callbacks. So you can imagine having nested callbacks and getting into callback hell. So it's kind of a trade-off. So let's just stick with this for now. And the way you would kind of deal with this in a large code base, I wonder how VS Code deals with this, because they do even more manual stuff related to disposing of instances. Maybe they have their own linter or something. There's tons of stuff you could do to ensure this. But yeah, anyways. So this is what we've done now. We have, we're ensuring that whenever we are authenticated, we go and grab the sandbox. And then we say that it's loaded. And that allows us to return the new state, which is ready. And yeah, we can move into later what we're going to do there. And this will be error. And then the error would be message.error. Cool. And what we should really do here is we should guard this. So if this state current equals pending, that's when we are allowed to move into ready. I do not see how this could happen in this specific case. But it's always good to have these guards. And if this data current equals pending, it's the same thing here. Oh yeah, it's the break thing here. Cool. And we would, of course, if there's an error, we would have like a retry thing. So you would have like retry requested or something, and then it would do that. Anyways, I think that's how long have we been going now? Oh shit, over an hour. Okay. Anyways, I think I need to find some time to fiddle around with these fixes. But next time we'll go into actually loading the different features that is part of the editor. So that would be the actual sandbox, because we only have the data for the sandbox now. We want a sandbox feature. We also have like other features like deployment, Git, the preview, other dev tools, yeah, stuff like that. So that's going to be interesting to take a look at. Okay, that's it for now. I hope, please let me know where it becomes less interesting so I can focus on what kind of gives you the most benefit. But I'm kind of doing this for myself as well. I really enjoy talking through what I'm thinking. And this is like, I'm trying to prove a concept here. And yes, I kind of have to talk about everything. Anyways, have a great day, and we'll talk tomorrow, hopefully. Bye for now.